NASA successfully nudged Dimorphos into a different orbit, but was off by a factor of 3 in predicting the change in period, apparently due to the debris ejected. Will we also need to know the composition and structure of a threatening asteroid, to reliably deflect it away from an Earth strike? NASA's DART strike on Dimorphos modified its orbit by 32 minutes, instead of the 10 minutes NASA anticipated. I would have expected some uncertainty, and a bigger-than-predicted effect would seem like a good thing, but this seems like a big difference. It's apparently because of the amount debris, hurled out into space, creating a comet-like trail of dust and rubble stretching several thousand miles. Does this discrepancy really mean that knowing its mass and trajectory aren't enough to predict what sort of strike will generate the necessary change in trajectory of an asteroid? Will we also have to be able to predict the extent and nature of fragmentation? Does this become a structural problem, too? Because of the relatively tiny size of the target, Earth, compared to the huge distance being covered by the asteroid, almost any change would be enough to cause something that would hit the Earth miss instead. It's also incredibly unlikely that we would accidentally knock it into a path that hits something else instead. So for the purposes of planetary defense, no, we don't need more information. It would be useful to understand how those other variables affect the deflection if we wanted to guide it to a specific target or orbit, for example if we wanted to mine it. Many asteroids aren't a solid rock like it's often depicted by movies and TV. Many are simply clumps of material loosely bound by gravity. In hindsight, it's not too surprising to me that there was this much ejecta. I suspect the researchers knew this was a possibility, but assumed the asteroid in question was more solid. In theory, if we can deflect the asteroid far enough in advance, we can send a probe with the ability to scan the asteroid up close first, followed by the impactor. Changing its trajectory in flight, we could account for any unexpected structures, densities, etc. That probably wouldn't be particularly helpful. Once we know it is going to hit Earth, if we have 2 windows for an intercept course, we will be better off hitting it as soon as possible in case the mission fails. Hitting an asteroid too hard isn't really a problem, it would just miss by a greater distance, so we can just send up a craft that has enough energy to do the job even if we don't get a lot of ejecta. And if we do, that's fine too.